A couple of things to keep in mind. If you have any questions during the session, put them in the chat window. If I'm not already discussing something, I'll try and answer the question then and there. Otherwise, every 15 minutes, I'll take a pause and try and answer the question then. Right, but all of your questions will be answered. So don't feel that we are not here to answer your questions. They will be answered, but you might have to wait based on when you ask your question. Okay, so let's quickly talk about the agenda. What we're going to be discussing today. We're going to be talking about cloud computing in general. What is cloud computing, and why should you even care about cloud computing? Then we're going to introduce AWS, Amazon Web Services. We're going to talk about Amazon Web Services, and obviously I'll talk about why we can't cover all the services in one slide, because that's literally impossible because there are so many. We'll also talk about AWS pricing options, and then quickly do a demo of hosting an EC2 instance and running a website on top of it. Right. So these are some of the things that we're going to be covering during the next 1 hour. All right. So first of all, what is cloud computing? So cloud computing is basically going to offer you computing services on the cloud, which is basically dispersed data centers across the globe, where you can do things like maybe store data, maybe get computing power, maybe run a database, maybe run a website. And you do all of that over the internet, where you can connect to the console provided by the provider who's offering cloud computing services over the internet. And once connected, you can do things like, upload your data, run a website, or, create a server where you need some processing power, maybe run some big data jobs to process data and so on. And whatever you use, be it storage, be it processing power, whatever you use, you pay as you go. So that means that let's say that you ran a job which required a huge amount of computing to do some analysis, and it required a huge amount of processing powers. And initially, what you would have to do is you have to go and procure servers on your own, the hardware, which would be consisting of course, you have to purchase SSDs or hard disk drives. You probably have to purchase some RAM. You have to purchase processors, and once you have all of that, you have to provision an infrastructure like a data center and get all of that up and running, and then run your job. Now, the only thing is that for a small job, which only for a job that only takes around 24 hours to run, what are you going to be doing with that infrastructure afterwards? Maybe you need it once in a month, or maybe you need it once in a week, and so on. So basically, you're going to be paying upfront, doing a capital investment on all of that infrastructure on day one. And then, even if you use it once a month or once a week, you'll have to live with it. But on cloud, you can just go there and spin up the infrastructure based on your requirement and do whatever needs to be done, and then shut it down. And then come on the next day, whenever it is, next month, next week, or maybe next year, run it and only use it for 24 hours and then stop it again. So instead of paying upfront and investing into a piece of hardware which is going to be of no use, it's going to be after 3 years cycle, it's going to run out of support unless you have extended support. Plus, it's going to be an old technology as well. You can just go to cloud and be like, okay, give me the latest technology and run this job on that technology and give me the output. And after 24 hours, you are done. And you only pay the cloud provider that 24 hours usage that you have actually used, right? Each and every cloud provider that you're going to be working with. Now, there are many outside in the market. There is AWS, of course, which we're talking about. There is a Google Cloud Platform as well. There is OCI as well. There is Azure as well. There are other vendors as well. There are other market players who offers these services as well. Now, you can use any one of those, right? And each might have a benefit over the another, or each might fit your requirement based on what you're trying to do, based on your licensing requirements, based on your workload requirements, and so on, right? But something to understand is that they all offer something very common, which is offering infrastructure as a service, where you're going there to purchase some infrastructure, like set of servers and network and so on. They all offer platform as a service, where you offload your resources onto that service that's going to be offered, and they take care of the rest. Like, for example, what are some of the challenges that you would probably face if you're hosting a website? If you're hosting a website, you'll obviously need to think of Okay, where is this going to run? What operating system I'm going to be using to run this website? How do I take care of backups of this website? How do I take care of scaling of this website? And if I'm doing scaling, I'll also need to load balance the traffic that's coming onto my website. How do I manage, maintenance and version control of this website? So how do I do all of that? Now, in a traditional infrastructure model, you have to do all of these things on your own, and you need to hire administrators like server administrators or app support guys to handle all of this stuff for you. But if you were to go to platform as a service offering, then all of these things are taken care of already as a part of the service offering. So now, instead of spending time and effort on managing your infrastructure, you simply offload that infrastructure. You focus on your business and your core logic and your code, and you upload it to the cloud provider service, which is platform as a service offering. And then the platform as a service offering will do all of these things for you, right? And lastly, we have software as a service, where you just want to consume a software and that's it. You're not worried about online, on-prem installations to use a particular product. Example could be you have a workforce and they need to collaborate with each other. They need an online solution which helps them share files effectively and securely. Or you have a workforce who needs to work on Excel files or Word files, and those files needs to be shared with everyone within the company, right? Or maybe securely shared with a group of personnel in the company. So that's where we have software as a service offerings. And you've already used some of these like Google Drive, OneDrive, Office 365, Google Suite of Office Productivity Suite, and so on, right? So each cloud vendor that you would normally go to will have a range of these kind of services that you can consume, which is characterized under infrastructure as a service, platform as a service, and software as a service. So whenever someone talks about cloud computing, the first thing that comes to your mind should be like, okay, they're going to be offering a range of services like infrastructure, platform, and software. And the model that they have is a pay-as-you-go basis. Now, again, to save money, you can also do things which we'll explain later, right? But which is like making a commitment and saying that, okay, I'm going to be using your services for 1 or a 3-year term, right? And based on that, you can make that commitment and, get more benefit, but otherwise it's going to be pay as you go basis. And these are the things that you can expect. Okay, that's what a cloud computing model is in general, right? Now, to offer this, they have to make sure that there are some data centers in the background. And how do they do it? I mean, every vendor has their own way of doing it, but we're going to talk about AWS over here. All right, so actually, before we actually go and talk about AWS, we need to talk about some advantages of cloud computing as well. So first thing that I mentioned was you don't have to invest in terms of capital investment, like purchasing servers and so on, right? You can just change it with operational costs rather than going and purchasing servers and investing so much in the servers. With CapEx, you can change this with OpEx, where what you'll end up doing is that instead of purchasing servers and then paying for the servers and that hardware, the vendor has already purchased it, and you'll only pay the vendor for the time that you use it. You also get benefit from massive economies of scale. Now, how does that work? That works in a scenario where you go to the vendor, right, and you purchase something. Now, someone else comes in and purchases, a similar thing from that vendor, and so on. People keeps on increasing. Now, when more and more people start coming and using the services provided by provider, the cost of operating that data center in that location decreases. Now, if the vendor has less cost to operate a particular data center in a particular location, what they do is they give you the benefit by reducing the cost of the services. For example, if a server with X configuration is going to cost $10 on day one, when there are 10 or 20 people connecting to the servers, or there are 10 or 20 more providers or more consumers of that particular provider, then the cost of that service will reduce. Okay, let me quickly check. Guys, are you able to hear me? Can you see the screen? Can you hear me? Or are you guys facing any issues? I mean, obviously, if one or two guys are facing an issue with because of their network speed or whatever, then I can't do anything about it. Shantini, yes. Thank you, guys. Thanks for confirming. So I see a bunch of yeses. So definitely not me. So that's definitely not my network connection that's faulty over here. So if you're having a network connection issue, try and disconnect and try and log in, right? And of course, the recording will be shared later for this session anyways. So, if you're facing issues, then, work out your network, guys. I can't honestly help you with that. Okay. Now, coming back to the slides. So more and more consumers using a provider, the benefit is going to be given back to the audience as well, right? Then we need to stop guessing about capacity. So earlier, the issue that individuals used to have was that, okay, how much RAM are we going to be needing? How much CPUs are we going to be needing? Or how much, resources are we going to be needing? So, okay, I mean, how do you decide that? How do you do that capacity planning initially? And it was difficult for most of the individuals. It was very difficult to do capacity planning. And that's why we required architects to do capacity planning. And the more experienced the architect would know that how big a challenge was it to do proper capacity planning. And most of the times they would go wrong. Now, you don't have to do that with the cloud because the resources can be created on the fly. You can create resources whenever you want. You can scale resources whenever you want. You can add resources. You can increase the capacity of the fleet of servers that you are operating with, right? With the things that cloud offers like auto scaling, or maybe by scaling it vertically, or scaling it horizontally using something called auto scaling. So you don't have to guess for capacity anymore. There is monitoring in place that can help you scale whenever you need to scale. Increase speed and agility. Now, how does cloud computing help you increase speed? As a business who runs a website in India, right, and they want to run a similar website for a different group, let's say in Australia. If you were someone who were to do this initially when there was no cloud computing, I had to move to Australia for some time, find a data center, maybe a co-location data center in Australia, and then host resources, purchase servers, put those servers, get connectivity back to India, right, to make sure that I can connect to the servers without being in Australia and get all of that sorted. It used to take a lot of time, right? And this used to affect me as a business because now if I'm thinking about going global in, some time, it will probably take me a year and it will be a very slow-paced effort to go global. Plus, it's going to take a lot of time, so it's slow. With cloud computing, you can just go to a region, switch the region, and create resources on the fly. And we'll see this in the demo section as well, where we can just switch the session to switch the region, and voila, you are in Australia. And now you can create resources or servers inside of Australia, or maybe US, maybe Europe. So that helps you to go global in minutes, right? But also gives you the power to create resources whenever you need them, rather than going through a slow process of first procuring hardware, then creating servers, getting the teams in, provisioning virtual machines, and so on. Now that can be done within a few clicks, or better if you have infrastructure as code, like CloudFormation or maybe Terraform. You can create resources and you can document resources. You can even version control your resources as well. And finally, focus on what matters. Now, instead of thinking about, okay, I would need to hire a server administrator, I would need to hire a web administrator, and so on to manage my infrastructure, no longer required, because we have offerings which already does most of those tasks that these administrators would have done. Like, why would you need administrators? Why would you need people who sit in service desks to monitor things? Because you need to have monitoring and take action when something goes wrong. But what if the cloud offers services which is fully autonomous and they can take care of it for you? And now you're free from those stuff, so you can focus more on your business, your core logic, which is going to bring you more revenue or more business going forward. Now, this is where we are introducing AWS, right? AWS is a cloud provider, right? And we talked about that there are others as well, other vendors as well in the market, other players which offers similar services. But AWS is one of the most evolving platform which offers you services like infrastructure as a service, platform as a service, and software as a service that we've already talked about, right? So it's a cloud computing platform that started back in 2005, right? And back then, it only had a few services in there that you can use. Example was like there was a service called SQS which you could use to decouple your applications, and then there was S3, which was there to store data. So if you have unlimited amount of data and then you want to store it securely, durably, and have high availability at the same time, and store it at a very cheap cost, you could just offload all of that to S3, and S3 will take care of that. And then it started evolving from there. And at this point, right, if I'm not wrong, they have more than 6,000 services and features that you can use across many areas, be it infrastructure, be it machine learning, be it artificial intelligence, be it big data, be it networking, be it network security, be it any other area that you can think of. And we'll have a quick walkthrough through these services as well. Right? Okay. Then we have a question. How can we identify service that can be placed in a SaaS, IaaS, or PaaS? Okay. This is more of a question that you need to ask when you are migrating to a cloud platform, right? Okay, is this a service that is a candidate for infrastructure as a service? For example, you need you need flexibility. Okay, I want to choose the operating system. I should be able to go in and make changes afterwards, right? I should be able to control whatever I'm provisioning. I should be able to administrate whatever I'm provisioning, right? Then you have no option. You have to go with infrastructure as a service. So you control the entire infrastructure, and you are responsible for maintaining that infrastructure. The next thing is, I don't want to control the infrastructure. I don't want it, right? I want someone else to take care of the infrastructure. I don't care about the operating system as long as I can just run my website or focus on my data. That's it. I don't want to care. I don't care about any of that. Then you would just go to platform as a service. And if you are doing a repurchase when you are doing a migration, for example, initially you had users who had identities using Active Directory, and all they were really doing was like using Word, or they were using Excel files locally inside your office, where you had a license from Office to run it on-prem or maybe on user laptops using a VPN connection or something like that. And you don't want to manage all of that anyways now. You want a different provider where identities can be created and managed by the provider itself. You want all of these services to be offloaded in the cloud, where they can access these resources anywhere on the internet, right? Of course, securely by logging in and using their identities. Then you can go to Office 365. So you're repurchasing that entire solution that you were using initially on-prem to now use a cloud-based solution like Office 365 in this case, or you could just use G Suite, Google Suite of products, or there are other workspaces inside of Amazon as well, which allows you to use Office productivity suites inside of Amazon. For example, there's Work Docs, which allows you to play with documents inside of Amazon. There's workstations where you can provide your users with workstations where they can log in from anywhere on the internet and then do these things that they want to do, inside your environment. Okay, the difference between web hosting and AWS Cloud. See, when you go for a web hosting, all you get is a server that you would get from any vendor where you can host a website like GoDaddy and so on, right? It's just a web server. You are very limited to things that you can do. Like it's just for web hosting, right? And the other thing is that there is a limitation on maximum that you can go in terms of the resources that you will have. AWS Cloud is like an entire infrastructure. Whatever you could do on-prem, you can do on AWS. You can create networks. You can create as many servers as you want, and not just web hosting. You can do anything that you want. Maybe run big data. Maybe do AI. Maybe do storing a huge amount of data like in TBs or petabytes. You can do all of that in AWS Cloud. So, I mean, it's totally a different beast altogether. Can we restrict access to the services only on specific IP range? Yes, of course. Yes, of course. You can create your own networks. You can manage your own networks. You can create firewall rules. You can manage full control of access of people who can actually access your AWS environment. And again, more on that, once as we move forward. Okay, now, how is the data centers or how is the infrastructure that is structured inside of AWS? So first of all, we have data centers, And where are these data centers located? These data centers are located within something known as an availability zone. And these availability zones are located within a region. So think of something like this, that a region could be Mumbai, right? Where Mumbai will have 2 or 3 availability zones, availability zone 1 and availability zone 2. And these availability zones are kept far from each other, and they constitute with a group or a single data center. And all of these regions are connected with each other using a backbone network that spans across the globe to connect all of the data centers with each other. And then we also have something called as edge locations as well, which I'll explain a little bit more about. But this is used for caching. So if you are placed very far away from a data center and you want the data to be cached locally to you, the edge locations are going to be the one which is going to help you cache that content locally to the end user, so the user doesn't have to take a round trip to the actual server location and get the data. And a typical example of this would be if you go to Play Store or your App Store, where are those apps stored, right? The files of those apps are maybe stored in a server in the US, but then if you were to go and download the content from the US server, it will take a lot of time, right? So to avoid that time, what is done is that that content is cached locally to you in an edge location somewhere in India, right? And then when you go and get that content, instead of you going to US and getting that content from that server in the US, you just make a request, and the edge locations figure out that this is already there in one of the cache locations, so you don't have to go to the origin, and the viewer can directly get the content from the edge location, which saves them time and helps them, improve the performance of their applications. Right. So the data centers is basically somewhere where they're going to be placing, tons and tons of servers, right? I mean, otherwise, how are multiple people going to get servers? There needs to be some data centers. I mean, at this point, you should understand that everything is not actually stored on cloud, right? There has to be some data center, some compute that is running somewhere to host these resources. And that's where the data center comes into picture. These all data centers are online, which means they're always running, and they always have capacity to host resources, to host servers, to allow you to store petabytes of data whenever you need them, right? These are sourced from multiple vendors, right? So you can, for example, if you were to go in and look for Intel-based processors, you'll find it. If you were to go in and look for, AMD-based processors, you will find it. If you were to go and look for ARM-based processors, you'll find it. And same applies to storage as well. So it's not just one vendor where they are, going to strictly source their stuff from. They have multiple vendors, and they would source all of this from these multiple vendors, right? And then, put all of that into the data center and get everything up and running. Now, these data centers are basically constituting a group of data centers, or maybe one data center would constitute an availability zone. And on top of this, we explained was the region. But what's the point of having availability zones? Availability zones are there because they are placed far away from each other within a region. So let's say in Mumbai, one data center is at location X, and the other availability zone is at location Y, which are far away from each other. Let's say 100 kilometers or 200 kilometers. Why? So if one of the availability zones were to go down, right, the other is not affected by it. Why would it go down? Maybe there's a fire, maybe there is an outage, whatever, right? So that outage will not affect availability zone 2 by any means. And these are connected to each other with a very high-speed private link, so that data can be transferred with very low latency between two availability zones. Now, the purpose of this is to offer you with high availability. If there are resources in one of the availability zones, if they were to go down because of an outage, you can quickly fail over or have built-in fault tolerance in your applications that would simply switch the users to the second availability zone where a second component of your application is hosted. So these users will obviously not see any downtime, right? Now, when I say all of this, people just simply assume that, and people who already have some experience with cloud normally would just assume that when you create resources, they're automatically replicated between availability zones, and whatever you create inside of AWS is highly available by default? The answer to that question is no. Do not build that mindset because it's absolutely wrong. As an architect, if you are working as a cloud architect, you are responsible to create highly available infrastructure. Now, depending upon the service that you're going to be using, be it infrastructure as a service, be it platform as a service, or whatever service you're going to be using, it comes with an SLA. And that SLA will tell you if these services can be created automatically as highly available services, or you need to create resources in a particular way, or you need to design your infrastructure in a particular way so that it becomes highly available. If the service by default doesn't come with replication across multiple availability zones, then you need to do it. You need to build an infrastructure in such a way that there is replication across availability zones to make sure that you have some resiliency in place. Otherwise, you get none, right? So there is no automatic replication unless AWS in their documentation says that, yes, this service has automatic replication from AZ1 to AZ2, or maybe AZ3 as well. Then we have regions. There are around 21 regions worldwide which host these availability zones. Now, regions mostly serve as a geographical location. There are two things that you will normally use a region for. Number one, keep your content closer to the end user. Number two, disaster recovery, right? So think about if there is an outage, there's a overall outage in the entire Mumbai. Maybe there is a power grid that has gone down and it's been down for like 36 hours and the backup generators cannot, operate more than 36 hours, right? And that has happened. Now the entire region is supposed to go down. So your availability zones will face the outage as well. So your both availability zones now are down. So in that scenario, you need to invoke a DR, which is supposed to be a different region altogether. There is supposed to be a Hyderabad region, which is supposed to come online in the future. But right now, the closest one that I can think of is Singapore. So maybe you can fail over to Singapore, right? And then create resources in Singapore to offer disaster recovery. The other benefit of having regions is that if your website or your resources or the data that is stored in that particular region, if users are going to be looking at that data or that application or those storage items that you're going to be publishing for the end users, then it is always going to be better if those resources are hosted directly inside of Mumbai, because then the users won't have to take a round trip across the globe to get the data. The servers are going to be from Mumbai, the user base is from Mumbai, so they can directly get the data from Mumbai itself rather than going to maybe US and get the data, right? So that helps with latency, right? Now, again, sometimes you start from one location and then you want to scale to other locations as well. So in that case, either you can switch to a new region, right? Or you can use edge locations, which we're going to talk about next. Just to see the overall infrastructure in one single layout, you can see that there are multiple regions in that orange layout that you can see, and it represents how many availability zones they have, right? So, for example, Oregon is one of the regions, which is one location across the globe, which hosts 4 availability zones, right? Similarly, California. Similarly, Mumbai has 3 availability zones, right? And there are some others as well, which might host 2, for example, Canada, right? In fact, once you see the Hyderabad region, it will initially have 2 availability zones, and then it will add a third one over the period of time. But then there is Virginia as well, which has 6 availability zones, right? So this is how they structure the data centers. So these data centers are located across the globe into multiple locations, right? They are constituted of availability zones to offer you resiliency and offer you fault tolerance and high availability. And they are created within a boundary of a region for a location for, obviously, why would you want to move data that is, Indian data to Canada? Makes no sense. So you have to create it, you have to keep it in India. And what's that boundary? That boundary is that region. So Mumbai is a region in India. If you're hosting your application inside of AWS and you don't want the data to cross Indian borders, where would you keep it? You need to create it in a region, and that region is going to be Mumbai in this case, right? So data localization, disaster recovery, globalization could be why would, and DR, of course, is why you would use a region. Whereas if you're looking for high availability, resiliency, and fault tolerance, that's where you will use availability zones. Right, then we have edge locations, and edge locations are in abundance. You can see that there are many edge locations instead, like the regions were like 20 and so on, like these are around 200, right? How this works is that we have something called as edge locations, and we have regional edge caches as well. Now, let's say there is a user, there's a pointer here. So let's say there's a user placed somewhere here in India, and then there's a user somewhere here in Australia. And they're trying to download some content, or maybe they're trying to watch a video, and that video is hosted on a server in an application somewhere over here in United States. So you went to the Virginia region and you created a server, and that server is hosting videos, right? And these users access those videos. Now, if the user was somewhere here near to Virginia region or within Virginia or somewhere in North America, that user will have very less latency to access that data. What if the user is in Europe? What if if the user is in India? And what if the user is in Australia? So these guys will have to travel this far, to get the data, which is, very high latency, of course. Now, how do you reduce that latency in that case? Now, to reduce that latency, you can use something called as edge locations. And we have a service called CloudFront inside of AWS that allows you to do exactly that. It allows you to cache the content locally. So in this case, when the first person goes and checks for the data, they will check the local cache to see if the data is already here. If not, then it goes to the origin and fetches the data, something known as an origin fetch. So once the origin fetch happens, the data is cached locally. And when the next user comes in, instead of that user going directly to the server and getting the data, he will directly get the data from the local cache. How does that help? If the data is local to that user in the same region, right, cached, low latency. That improves the performance of your website plus user experience. And similarly, if you have multiple locations that you're going to be using with CloudFront, which in turn uses edge location, that allows you to build applications which are good, high performing and offers low latency for their customers for static or dynamic contents. Right. Next is AWS Services. And there are so many. At the time of this recording, I believe that there are around 6,000 or 65,000 AWS services and features that you can use or consume. And there's no way, not 65,000, 6,500, sorry, 6,000 to 6,500. So I think these are the number of services that are there that you can consume, right? Now, I've put together a quick chart to showcase all of these services, right? Not all, some of these services to give you a quick explanation, right? But again, there are so many that there's no way that I can cover it, all of these. And I don't even know all of the services, to be honest. Like, there are so many. I don't know anyone who knows all the services that are there inside of AWS, right? We're going to talk about them from within, some of the areas like foundational services that you absolutely need to know if you're going to be working with AWS. Then application and management services that allows you to do DevOps or monitoring or maintenance inside of AWS. Then there are migration services that allows you to migrate inside of AWS, and then other services, say within mobile application development, IoT areas, or enterprise applications like software as a service that you see at the bottom, right? So starting with foundational services. Oh, before we go here, any questions, anyone? Okay. So from the foundational services, we have compute. So within compute, we have so many services, as you can see. There's EC2, which is like creating a virtual machine in the cloud. And then, you can choose the operating system and do whatever you want to do and install whatever you want to install, maybe a database, maybe a web application, whatever you want. right? And you can create as many servers, and of course, you can create a network before you create these servers as well. Then we have Lightsail, which is VPS hosting. So if you're looking to just host a web application or a WordPress site and you don't want to spend or do things like setting up a proper infrastructure for that, Lightsail could be an option for you. We have Elastic Beanstalk, which is platform as a service offering, where you would simply upload your code, be it your application, be it your API backend, or be it your web application, whatever. You would just host that application on top of Elastic Beanstalk by uploading your code. All the things like scaling, load balancing, connectivity to the database, and all will be taken care of by Elastic Beanstalk for you. Then we have AWS Lambda, which is a serverless offering. So if you're looking to build a serverless application or a microservices architecture inside of AWS, you can use Lambda, where things will run in the background without you actually seeing the server. So when we say serverless, it doesn't mean that there are no servers in the background. There are obviously servers in the background, but you don't see them. So those services seem to be serverless, right? But the benefit to you is that you have some code running in Lambda, and that code will do its thing, and it will shut down. So that means that something can invoke, and also once that is done, Lambda will shut down. So you only pay for the amount of time that you're going to be using the service for. And if you're someone who likes to play around with containers, and you're building a microservices architecture that is hosted on top of containers, then we have two options. We have ECS on the left, and we have EKS on the right. Now, ECS is a container orchestration engine provided by Amazon. Now, if you're someone who has used Kubernetes in the past, and obviously you like using Kubernetes because it's open source, right? Then you can use EKS, which is a managed service provided by AWS to host your containers and then orchestrate them using Kubernetes related technologies like pods, deployments, and so on. Now, coming to storage, there are multiple options in that area as well. The first one is Simple Storage Service, S3, the most commonly used service, where you can store petabytes of data. It's virtually unlimited. It's an object store where you can store as much data as you like, and all unstructured data, if you're trying to create a solution inside of AWS, would go on S3, right? Whereas if you're looking for something which will have a file system, like block storage for your operating system, and this that you're going to be attaching to your EC2 machines or your virtual machines, that is where you would need EBS, block storage. If you're looking for a file share where you can store data and share across multiple machines or even your on-prem servers as well, then you're looking for a file share service, which is truly scalable. It scales and offers you high availability, when you set it up as well. Then we have storage gateway. So if you are running solutions on-prem and you're running out of storage on-prem and you're looking to extend that storage to a cloud solution like S3, storage gateway can help you do that. Let's say you're running out of disk space and you want something to, offload it or tape, you have tape backups and you have archive data and you want that to be offloaded into the cloud. Storage gateway could be a solution that extends your on-prem storage to cloud storage. And for the end user, it's totally transparent. They won't even see if the data is actually stored on the cloud. They would still use the data as they were using it on the disk as before, right? For archival data, we have Glacier, which is super, super cheap. I think it's around $0.0003, for 1 GB of data, something like that, which allows you to store a large amount of data and archive it as well at the same time. And then we have Snowball, if you are moving petabytes of data inside of AWS, and obviously you can't move the data over the open internet because it's going to take lots and lots of time. So you can ship that data using something called Snowball, and you'll see Snowball also featuring in migration services as well. If you're trying to migrate data to AWS, Snowball is a service that features a lot there as well. Then we have databases. And databases, when we talk about databases, one of the most famous services that we have inside of Amazon is RDS, Relational Database Service, which allows you to host how many services? It allows you to host a SQL Server as a service, MySQL as a service, PostgreSQL as a service, MariaDB as a service, Oracle as a service, and their own proprietary Amazon Aurora as a service as well. So there are so many, right? So any database that you have used outside, any relational database, solution that you've already used somewhere before, you can just bring it inside of RDS and host it over there. The benefits that you get is that the patching will be taken care of by AWS. The backups will be taken care of by AWS, right? The provisioning will be taken care of by AWS. The high availability of those databases are going to be taken by AWS. All you have to do is simply migrate in and leave the rest to AWS. Maybe you're looking for a caching solution like running a Redis, or maybe running, one second, let me see. Oops, sorry. If I can zoom it. Hopefully that will help. Right. So we have a Redis, or we have a memcached, and you're looking to host a solution inside of AWS related to that. You can absolutely do that. Just use Elastic Cache, and it supports both Redis and memcached as well. Let's say you're trying to run a NoSQL solution, and you want a serverless solution for it. We have DynamoDB, where you can, create NoSQL schemaless tables and then run your solutions on top of it, right? Then we have Redshift. And Redshift is awesome as well. It allows you to do data warehousing, right? So you have relational, transactional data, right, which basically helps you do transactions. Like someone walked into your store, purchased a bottle of beer, right? What happened? You made a transaction. Now, what you want next is you want to find out how many bottles of a particular brand of beer were sold from a particular store in a particular month. Now you want to run analytics. So you ETL that data into a data model, a data mart inside of Redshift, which is a data warehouse. You store it over there, and you hook in, you do the ETL and convert it into a data model, and then you hook in your reporting tools like Power BI, or any other reporting tool that you're familiar with, like Tableau or so on. You hook it into Redshift and then run your analysis on top of that as well, like the use case that I said. So from OLTP to OLAP. And then finally, we have migration services as well. So you're looking to migrate all of that data, and it doesn't just migrate from, let's say Oracle to Oracle. If you're looking to migrate from Oracle to MySQL, it allows you to do that as well. It allows you to do schema conversion. It allows you to do replication and migrate the data inside of AWS with very little downtime, right? Whosoever says that there will be no downtime is actually lying to you. And whenever you are migrating the databases, the downtime that will incur during the cutover is going to be some downtime. So there is no service out there that can actually help you migrate without downtime. Then we have networking and content delivery services under foundational services, right? So you are looking to cache the content. We have CloudFront, and this is what we talked about with edge location. You are looking for a public DNS or a private DNS where someone comes to your website and like abc.com, and is taken to a particular web server or an IP address or a load balancer. Cloud 53 does that. You're looking to create your own virtual networks where you can keep your resources. VPC does that. You're trying to extend your on-prem network inside of inside of AWS, right? We have Direct Connect for that. If you're trying to connect between GCP or AWS or Azure or AWS and on-prem into AWS, we have VPN connectivity for that as well. So you can create a site-to-site VPN connection inside of AWS using client VPN as well. And then finally, we have API Gateway. If you're looking to host your APIs, which connects to a backend logic, maybe hosting on Elastic Beanstalk, maybe EC2 or whatever you're using, like Lambda, then you can host those APIs on API Gateway, right? So these are some of the foundational services augmented by management and application services, right? And there are so many. I mean, there you can see all the areas. How do you manage access? How do you make sure that the people who are going to have access to your environment have access, a secured access? So we have identity and access management. You're looking to bring in your existing Active Directory. We have directory services. You're looking to encrypt everything while bringing in the data at maybe rest or maybe in transit, right? If you're looking to do it in rest, we have key management service. We have monitoring and auditing services. You want to figure out like, okay, what happened, who did what in my AWS account. We have a cloud trail for that. So you see that entire trail of what's happening, right? We have a monitoring solution called CloudWatch, which allows you to set up alerts, metrics, dashboards to monitor entire infrastructure inside of cloud. And you want to make sure that, what's the status of your entire AWS account. You can use that using config. Now for deployment, we have CloudFormation, which is infrastructure as a code. You can code your entire infrastructure keep it in a file, and run it with self-service model. So you can create and destroy infrastructure whenever you need. How awesome is that? And you don't need any documentation because code itself is documentation for your entire infrastructure. If you're looking to do configuration management, we have ops work for that. And if you're looking to do automated patching session, automation across your environment, we have system manager for that as well. Another requirement could be to decouple an application, right? Where you want an event-driven application where something happens when an event occurs, right? So we have Event Bridge for that. We have SNS and SQS, and each works on a different model. Like SNS works on a subscriber and a publisher model, whereas SQS is a queue, which allows you to queue messages before they can be read, and something can be done about it by a worker on the other side. Similarly, we have analytics services, which allows you to run analytics. So Athena is a service that allows you to run analytics on directly on your raw data, let's say stored in S3 in Parquet format or CSV format. EMR is Hadoop. If you want to run Hadoop inside of AWS, then EMR is your service, and it's a managed one. If you have streaming data that is always flowing in, and you want to do, store that data and then run analytics on top of that, who would consume that data? That consumer will be Kinesis in this case. We have developer tools. If you're looking to build a pipeline, a CI/CD pipeline inside your AWS infrastructure, so the code can be delivered to your servers whenever there's a new update or a new fix to the code, you can use developer tools for that. We have machine learning services. For example, one is recognition. You feed it an image, and it will tell you what's there in an image, like fruits, dog, cat, so on. You want text to be extracted from an image. We have text extract for that. Right, we have media services, which allows you to do conversion of services as well. Right, there's a quotient and access ID and secret key is associated with the which IAM entity. When you create an IAM user, you can create an access key and a secret key for that IAM user, and whatever policies are associated with that IAM user will allow you to inherit these access keys, and as secret keys will inherit the same permission, so you can do something inside of AWS. Then we have migration services and some of the transfer services that allows you to bring data inside of AWS. So maybe you're trying to do server migration, so you need to discover and do TCO analysis for that. So we have migration services for that. Then we have services that allows you to use SFTP to transfer data inside of S3. We have a migration hub that allows you to do all of that, like discovery assessment, before you actually go and implement, server migration and do it at scale. Like AWS Server Migration Services, where you have hundreds of servers and you're looking to migrate it into AWS, and you want to, issue that migration by doing disk-based replication inside of AWS. You can do that, right? And then we have Snowmobile, which is an actual truck consisting of lots and lots of snowball devices. You have hundreds of petabytes of data, and you want to move it into AWS. They will actually send you a proper truck where you can upload your data, and then it will be shipped back to AWS, and then you will have that data on S3, and then you can do your migration on those services as well. And again, on top of that, we have mobile services, which allows you to build mobile-based applications, do identity management for those applications, host APIs for mobile-based applications, and sync it across devices as well. We have IoT services. If you have IoT devices, you're using those. There are services for that as well. And finally, enterprise applications, which allows your workspace to do things like work mail, work docs, a Chime for meetings and stuff, and then finally workspaces if you want to give VPN servers to your VPN hosts where they can connect to your environment inside of AWS or any vendor as well. Then we have workspaces for that as well. Right. The question Sunil has asked, AWS CLI, we can use access key and secret ID. Not just AWS CLI. Yes, you can use AWS CLI for that by just running a quick AWS configure, and then it will ask you for a access key and a secret ID, and then you can register and use it over there. But apart from that, access keys and secret IDs can also be used inside of your applications as well. If you're using any AWS SDK for maybe Python, maybe Java, or so on, you can integrate your access keys and secret IDs over there as well. But having said that, it's not safe to use access keys and secret IDs, because if you lose your access keys and secret IDs, then you're done, right? So a better way to do that is by using role-based access, right? And again, that is also something that you can do within IAM. And again, outside the scope of this particular discussion, but yes, that would be what would be advisable in case what you're trying to achieve, like using but and how that works is that you use STS to issue temporary access keys and secret IDs, and they get rotated on their own. Right. Now, coming to the pricing model, and there are so many services inside of AWS, right? And that's why there is no one pricing technique that could, be applied to everything, right? Normally, when we talk about pricing for EC2 servers because, that is where we can do distinctions, right? So for EC2 pricing, right, we have on-demand instances, which is pay as you go. Let's say the instance is priced at X amount. You'll have to pay X amount by the second, right, for that particular instance, right? Then we have reserved instances where you go and say that, okay, this instance is priced at X amount. Hey, AWS, I want to reserve it for 1 year or a 3-year term. Why don't you give me a discount? AWS says, yeah, why not? You reserve it for 1 year term or a 3-year term, and we'll give you up to 70% discount on these instances. But the problem with the reserved instances is that you are reserving instances, right? What if you want to change the instance, like, they have launched a new processor type, which is much faster and offers, better performance, but at the same price, then you have to upgrade that instance, but reserved instances won't allow you to do that unless you were using a convertible reserved instance, right? And there could be other issues like, okay, what about, capacity? What if I wanted to just reserve capacity? And there are some solutions like Fargate as well, which also allows you to do reserve capacity as well, which is fully managed compute. So what about that? So for that, we have saving plans. Now, instead of reserving instances, you are just reserving compute capacity. Okay, I need 26 processors, right? And I need around 1 TB RAM or something like that. So you're reserving capacity and again, getting up to 70% discounts on that. And then we have spot instances where you can just go and bid for instances. Like, if the instance is at X amount, right? So X divided by 8 is the current bid, and you just, make your bid and you get the instance. The higher the bid, you get that instance, of course, right? But the only problem is there are no SLAs. Why? Because someone outbids you, that instance is gone because he has a higher bid. So he gets that instance, he or she gets that instance in that case. Right, so there's a question, hosting cost of simple PHP Java site, where I can get these details. Yes, of course, I'm gonna talk about that next. Now, you wanna do things like this, like, okay, I want to host a simple application, right? How do I calculate the cost for that, right? There is a calculator, right? And we're gonna look that into action now. So let's say I want to find out the cost for a simple application, right? So first and foremost thing is, you need to ask what all things will this application have. So for a simple PHP and Python-based application, right, I might actually ending up using a small server. So I'll go to EC2 and I'll say it's a web server, right? Hosted in, let's say it's, for Indian user base. So the closest region I should be putting it in should be Mumbai. So let's look up for Mumbai from the list. And there you go. Change region. What operating system are you going to be using on that instance? I'm fine with Linux. What instance are you going to be using? I know for a fact that T3A, because they are AMD-based processors, are going to be charged lesser. So one server, which is going to be utilized 100%, and I'm going to be using it for 1 year, right, for using a savings plan, or I can go on demand. So if you're going to be going with on demand with around 30 GB of storage as the base, you're going to be charged this much for that server. And how much RAM and CPU do you get? You get 4 GB of RAM and 2 vCPUs, right, for this much amount. If you change this to a savings plan for 1 year, you get a $6 discount. And if you go for a 3 year, then you get almost half the price. And if you pay the entire amount now, you'll pay this much. And this is actually for 3 years, not just 1 month, right? So you see the benefit there, right? And once you're done, you can calculate all of that, put that together, and even share that estimate or export that estimate to show to others as well. And again, this is a very simple example. There could be other ways to host, simple static websites just by hosting them on S3 as well. How does AWS pricing strategy works? How you support pay extra for EC2 billing? You're supposed to pay extra for literally everything that you use. Cloud is a pay-as-you-go model. So whatever you're going to be using, you have to pay for it. You have to pay for it. So if you're using EC2, you pay for it. If you use any other service, you pay for it. You can host static content in AWS S3. Absolutely, you can do that. Yeah. In fact, I just hosted a website for someone using S3 yesterday. But the problem with hosting websites on S3 is, how do you apply HTTPS? Because S3 doesn't accept certificate. What do? For that, you can use CloudFront. So CloudFront allows you to host a certificate. So use CloudFront on top of it. That gives you caching capability for your website on S3. So it is, could go anywhere. Plus, it also allows you to host HTTPS as well. So great, so it does both the things. So S3 plus CloudFront is a proper solution for hosting a static website, and then Route 53 to send traffic to CloudFront as well from there on. For EC2, and you need a certificate as well. So we have something called ACM as well. So you can use AWS Certificate Manager, where you can issue public certificates for free, and then link it with, or you can bring in your own certificates as well if you like. For EC2 instance, does Oracle is better option compared to AWS? Does Oracle Cloud is giving VM as a free of cost? There is no cloud provider out there that gives you a VM for free, right? Unless it's a very small VM and you're in the free tier. If you are not inside a free tier, no one will give you a VM for free. No cloud provider does that. Do we also get a contact person from AWS while migrating or implementing? Yes, depends on how does that migration look like. If that migration is, I want to migrate a small WordPress site that's going to be an annual bill of $200 on AWS. Of course, no, they don't have bandwidth for that kind of a project. I want to migrate an infrastructure which has 1,000 servers, and I want to migrate that into AWS, right? And I have a support model, enterprise-based support model, and I'm paying AWS around $400,000 per month to AWS, right? Yes, of course, they'll give you a team within AWS for that, right? So depending on the size of your project and your support model, and it does cost to have a support model inside of AWS, by the way. Based on that, they will give you a dedicated manager inside of AWS, or maybe even a dedicated team to help you with migration. But normally, with smaller projects that you are executing, you don't get AWS support because it's too costly. And even if you go to AWS asking for support, they will redirect you to a partner where it will be more feasible for you to arrange a pricing model where these consultants who have tons and tons of experience inside of AWS, like I do that. There are many, vendors who come to me that we are looking to migrate into AWS. Can you help us? Yes, of course. Why not? What is the scope of Amazon VPC? It's region scope. It doesn't go beyond the region. So when you create a VPC, it's a scope where it's basically inside a region, and then you create subnets which are scoped is inside an availability zone. All right, with that out of the way, let's pull up another one, and let's do that quick demo that we talked about, right? So we're going to launch a small instance, and I'm not going to talk about like how to launch an instance because again, we're outside the scope and we are already out of time, right? So I'm just going to launch a simple instance here inside of AWS. I'm going to be using the Amazon Linux machine, and then pick up a small instance. Let's go for T3A. E3A sounds much better with 2 vCPUs and 4 GB of RAM. That looks good. So let's just take that, and I'm going to leave everything like VPC selection. Again, you can do all of that. You can select your VPCs, your sizing and all, right? There are very large instances that you can create. So I think someone asked about web hosting. This is not a web hosting solution. Like AWS can host websites, but it's not just a web hosting solution, guys. It's way more than that. It's like your entire infrastructure, whatever you know in IT, whatever you have done in IT, or people are doing in IT, and even if you don't know anything about like IT, whatever you can think of in IT is all embedded in this one console. I can switch between regions. If I wanted to, right now I'm spinning it in Virginia. If I wanted to move to Ohio, I can just do this. And I am in Ohio Data Center, guys. This is amazing. You can think of like this as a proper solution for hosting any infrastructures, any kind of infrastructure that you're looking to host, right? Let's add storage. 8 GB is going to be fine. I want to encrypt it as well while I'm at it. Let's add a tag, name, and give it a demo. Demo 1. Configure security groups. Someone asked, like, can you control the traffic in firewall? Yes, of course. Why would they have a non-secure solution, guys? That's de facto. They'll obviously give you something that allows you to allow traffic. Okay, I need TCP access, but yeah, apart from that, I need probably SSH. And apart from that, I probably need HTTP access as well. Let's see, I don't have one, so I'm just going to create a new one. So class underscore SG. Apart from that, let's do HTTP because it's going to have a website, and I can allow HTTP traffic. I can control my IP address only from me. Again, yeah, anywhere for HTTP, but for SSH, just my IP. So no one can SSH into this instance as well. So review and launch, and I need a key pair for it. I already have this key pair, and again, launch the instance. And the instance is up and running. So you can see that I have a instance that was just created, probably still coming up. And there you go, demo 1. So I can see that there is a small instance over here. Let me change this to top. And you can see, again, you can see that I have a few other instances as well, which are in stopped state. I did a lot of things over there. I was testing a health check tool over here, and I shut it down after. You know why? Because once you shut it down, you don't get charged for it. And now it has everything that I need. I can start it up whenever I need to resume my work. How awesome is that? I'm not paying anything for these instances. I can restart it like for a couple of hours, do all my work, send the reports and everything, and then shut them all down again. Pay for only 2 to 3 hours. So proper pay-as-you-go model, guys. Right, and then coming back to the demo instance that I have, it has a public IP address. So let's try and connect to it. And okay, CD downloads, AWS, say Pro, LS, that's where the key pair is. Okay, SSH-I, EC2-user, EC2- the key pair, and then EC2-user at the rate that IP address that I copied paste. Done. And that should allow me to connect to that instance. And yes. And I should be able to SSH into that instance. And yeah, I am in that instance now. It is connected. You can see EC2 and the IP address, private IP address of that server. So sudo yum install httpd ny. Let's install a web server. If you never work with Linux, then you can do it on Windows as well by installing IIS using the GUI, guys, as well. So service httpd start. And I need to be an administrator to do that. And sudo check config httpd on, just to make sure that the service is set to auto cross restarts. It doesn't matter. I'm going to shut it down anyways after that. So let's take that and do this. Voila, my website is up and running. I mean, of course, I haven't done anything, but it's serviceable. Now I can just go to this location and add my web pages, and from there on, I can run my complete website over there as well. How awesome is that, right? And how much time did it take? 5 minutes. And with that, we've also run out of time as well. So cover a bunch of things. Talked about cloud computing, talked about AWS and its infrastructure. I talked about a bunch of AWS services, which is going to be very difficult to remember, but you can see that there are so many. Like I didn't have quantum technology, satellites, and blockchain and so on, robotics as well, right? So there's so many. No one can talk about them in 1 hour, or no one can talk about all of them because no one knows all of them as well, right? Even I don't, right? So there are a bunch of services, of course, and then we also looked at costing of these instances and these servers inside of AWS, and then very small demo of hosting a quick website inside of AWS. And I don't want to incur any further costs, so let's just terminate this instance as well. And we are done. No more costs. I'll be charged for a few seconds that I ran it for. That's it. All right, guys, that's all I have. If you have any questions, let me know. Otherwise, we'll call it a day, and you guys can go back to your work and think about how amazing AWS is, and then decide if you want to learn it further. I see a repeat question. What is the scope of an Amazon VPC? The scope of our Amazon VPC is within a region. So if I go into VPC, you can see that it is hosted within a region. Yep, there you go. It's hosted within a region, and it doesn't scope beyond that. So we don't have global networks inside of GCP. Oh, sorry, inside of AWS. We have global networks inside of GCP, by the way. Thank you, guys. If you like the session, that's great. That was the whole purpose. And I really appreciate your feedback. All right, guys, if there is nothing else, we'll call it a day. And thank you for attending. And I hope you learned something out of this.